Hello everyone. Today topic is related to examples on integral power of the matrices. Now first example is we are given matrix A is equal to 1 2 4 1 of the order 2 by 2 and find the value of A square plus 2A plus 7I. I means identity matrix. Now first calculate A square. A square is equal to A into A. That is equal to 1 2 4 1 into 1 2 4 1. As a rule of multiplications we get 1 plus 8, 2 plus 2, second row, 4 plus 4, 8 plus 1. And resulted matrix is 9 4 and 8 9. And 2A is equal to 2 1 2 4 1. By scalar multiplication of the matrix we get 2 4 8 2. Similarly 7I that is equal to 7 1 0 0 1 that is equal to 7001. Now find the value of A square plus 2A plus 7I that is equal to 9489 plus 2482 plus 70 and 07. Now add up the corresponding elements of the matrix. We get 9 plus 2 plus 7, 4 plus 4 plus 0, second row, 8 plus 8 plus 0, 9 plus 2 plus 7. So resulted matrix is 18, 8, 16 and 18. That is a result. Now, second example is we are given A is equal to 4, 3, 2, 5. That is a matrix of the order 2 and we want to find the value of x and y such that given equation is A square minus xa plus yi goes to 0. Now first find out A square. A square is equal to A into A and that is equal to 4325 into 4325. As a rule of matrix multiplications we get 16 plus 6 and 12 plus 15, second row, 8 plus 10 and 6 plus 25. And resulted matrix is 22, 27, 18 and 31. Now A square minus xa plus yi is equal to 0. That means substituting the values 22, 27, 18, 31 minus x 4325 plus y 1001 that is equal to 000. Now add up the corresponding elements of the matrices. We get first row 22 minus 4x plus y, 27 minus 3x plus 0, second row 18 minus 2x plus 0, 31 minus 5x plus y that is equal to 000. Now by equality of the matrices, equate the corresponding elements of the matrix. So we get 22 minus 4x plus y goes to 0 and 31 minus 5x plus y goes to 0. Number 2, 27 minus 3x goes to 0, 18 minus 2x goes to 0. Now equation 3 and 4 we get x is equal to 9. Now substituting the value of x is equal to 9, equation 2 and solve it, we get y is equal to 14. And third example here we are given A is equal to 1 minus 1, 2 minus 1 that is a matrix of the order 2 by 2 and B is given A minus 1, B minus 1 again matrix of the order 2 by 2 and we are given the condition A plus B whole square that is equal to A square plus B square and we want to find the value of A and B. Now first we are given A plus B square is equal to A plus B. A plus B square को कैसे लिखोगे? We will write A plus B into A plus B. As we know matrix multiplication is not commutative, so we cannot direct apply the result a plus b square is equal to a square plus 2ab plus b square. So we solve it one by one. We apply distributive law. A into a plus b a plus b, that is equal to a square plus b square, and that implies a into a plus a into b plus b into a plus b into b, that is equal to a square plus b square, and that implies a square plus ab plus ba plus b square is equal to a square plus b square. By cancellations, we get the result ab plus ba, that is equal to 0 matrix. Now calculate ab plus ba, that is equal to 1 minus 1, 2 minus 1 into a minus 1, b minus 1 plus a minus 1, b minus 1 into 1 minus 1, 2 minus 1, that is equal to 0 matrix. Now multiply, we get a minus b minus 1 plus 1 second row, 2a minus b minus 2 plus 1 plus a minus 2 and minus a plus 1 second row, b minus 2 minus b plus 1, that is equal to 0 0 0. Now adding the corresponding element of the matrices, we get a minus b plus a minus 2, 0 minus a plus 1 second row, 2a minus b plus b minus 2 and minus 1 minus b plus 1, that is equal to 0 0 0 0. Now equating the corresponding element of the matrices, we get 2a minus b minus 2 goes to 0, minus a plus 1 goes to 0, 2a minus 2 goes to 0, and that means minus b goes to 0. So we get the result a is equal to 1 and b is equal to 0. And next example है, we are given a is equal to 3 minus 5 minus 4 and 2, and we want to find the value a square minus 5a minus 49 and hence find out the a cube. Now first calculate a square. A square is equal to 3 minus 5 minus 4 2 into 3 minus 5 minus 4 into 2. Now multiply, we get 9 plus 20 minus 15 minus 10 second row minus 12 minus 8 and 20 plus 4. So resulted matrix is equal to 29 minus 25 minus 20 and 24. Now find out the value of a square minus 5a minus 49, that is equal to 29 minus 25 minus 20, 24 minus 5, 3 minus 5 minus 4, 2 and minus 14, 1, 0, 0, 1. Now by scalar multiplications, we get the result 29 minus 25 minus 20, 24 minus 15 minus 25 minus 20, 10 minus 14, 0, 0, 14. Now adding and subtracting the corresponding element of the matrix, we get the result 29 minus 15 minus 14 minus 25 plus 25 minus 0 minus 20 plus 20 is equal to 0, 24 minus 10 minus 14, we are getting this matrix is also equal to 0 matrix. So a square minus 5a minus 14i is equal to 0 matrix. Now multiplying both sides by a, so we get a into a square minus 5i minus 14i, that is equal to a into 0. So that means a cube minus 5a square minus 14ai goes to 0 matrix. Now transposing the two terms, we get a. Now a cube is equal to 5a square plus 14a. Now substituting value of a square and a, we get 5 into 29 minus 25, second row, minus 20 and 24 plus 14. 3 minus 5 minus 4 and 2. By scalar multiplications, we get the result 145 minus 1
minus 125
minus 100 120 plus 42 minus 70 minus 56 and 28. Add up the corresponding elements, we get the result
187
minus 195 minus 156 and 148. That's the result. And last example is when we have to prove the result by natural numbers and which are infinite. How to prove it? We apply the induction method. Now we are given a is equal to 3 minus 4 1 minus 1 and prove by induction method, that is a raised to power k is equal to 1 plus 2k minus 4k, second row, k minus 1 minus 2k, where k belongs to positive integer. Now, for this, we prove the result for k is equal to 1. When we put k is equal to 1, we get a is equal to 3 minus 4, 1 and minus 1. So, result is true for k is equal to 1. And second step is we assume that result is true for k is equal to m. That means a raised to power m is equal to 1 plus 2m minus 4m, m 1 minus 2m. And next step will be we will prove the result for result is true for k is equal to m plus 1. And hence the result is true for all set of natural numbers. Now calculate a raised to power m. A raised to power m is equal to a raised to power m. Now calculate a raised to power m plus 1 and that is equal to a raised to power m into a. So that is equal to 1 plus 2m minus 4m, second row, m 1 minus 2m into 3 minus 4, 1 minus 1. When we multiply these two matrices, we get the result. First row 1 plus 2m into 3 plus minus 4m into 1, 1 plus 2m into minus 4 plus minus 4 minus 1. Second row m into 3 plus 1 minus 2m into 1, m into minus 4 plus 1 minus 2m into minus 1. Now calculate these terms. We get 3 plus 2m minus 4 minus 4m, second row, m plus 1 minus 1 minus 2m. Rearrange these equations terms. We get 3 plus 2m can be written as 1 plus 2 into m plus 1. Similarly, minus 4 minus 4m can be written as, taking out minus 4 common, minus 4 1 plus m. And next m plus 1 and second 1 minus 2m can be written as 1 minus 2 in bracket m plus 1. So we see the result 1 is true, also k plus 1. Hence by induction method the result is true for all integers, positive integers. That's all. Thank you.